While Sam or Gary comes around to stamp your homework.
Wait, Jose. Jose. 26. No, 25 and 30. Jose, is that whole thing 22?
Do you have 25 and 30? I'll take 5. No, it wasn't the 30. Hold on, you have to wait. Why do you have to? What's the window on 35? It was 26 to 35. Great name and all that.
Recently?
Probably like at least 2,000. I mean, I think it is. Number 20.
As soon as Sam's done with the stamping, we're going to rush through a few study goals today. We have much to discuss. I think we might be able to maybe can do it. I don't know. Probably not. Thanks, broski.
Yeah.
Okay, students, a couple of quick announcements, then we launch. The Green Club event this weekend requires a waiver. That waiver is on the Facebook group. But if you are not available for printing off the internet, I have a couple of copies right here. Please look up. And now that we may not have movies, it's especially important that you consider this option.
Wouldn't that be for last unit?
Right. Yeah, this assignment does apply to the previous unit. Yeah, that's right. This extra credit applies to the previous unit. Is correct.
Aren't we having movies?
What?
Aren't we having movies?
Because I don't know how to make them legitimate. I don't really have a way to make sure that students do the work. Like, the more I ask, the more I'm getting reports of kids, like, not being here for them, or walking in the last minute and copying the paper from somebody else, leaving halfway through the movie, and then, like, kids talking, like, half the class talking and half the class watching. Like, I thought I had, like, pretty good controls of the quality of the movie times. But I've been talking to some of the parents, and they're like, "No, that's a total joke. Like, nobody does shit." That bums me out. I mean, nobody does anything. Yeah.
If you like filmed the kids while they watched it.
I've been thinking about that. That might do it, but then it's like the other round. Exactly, it's that other thing where like it's kind of a lot of work for me to do the films, to be honest with you. Like, just making sure that we have the papers and, like, screening all the movies. Like, I kind of changed the series. So, like, I have to add a movie to this unit, for example. That's, like, 3 hours I got to spend to, like, write up the thing and get it photocopied and all that. And, like, I don't know. I'm sort of frustrated by it. All right. Remember that the water bill is due right after the 4-day weekend. If you haven't already asked the city of Santa Barbara, this is your last day. Because, you know, there's a 4-day weekend coming up. Yeah.
I'll ask it.
Okay. And if your parents do not pay for water, which I'd be very surprised about, then they can write me a letter. But if the letter says we didn't keep our bills, then I'm sorry, that's why I warned you in August. Okay. Oh, an important deadline. If you want to get accommodations from the college board, you know, like extra time or preferential seating or large print or whatever, like people who have a 504 at the school could usually qualify for that. Please note, it's separate. If the school gives you that, that doesn't mean the college board will give you that. It's a similar application process. That deadline is February 20th. So if somebody here qualifies for extended time at the high school, you should probably qualify there, but you got to do an extra round of paperwork for that. Are there any questions about that deadline? So where did we leave off last time? Had we seen this? Yes? Had we seen this?
Yes.
So what is this? Electrical generation. What is this?
Industrial supply?
In the city, what do we use most of our water for? Lawns. Irrigating lawns. And inside your home, where do you put most of your water?
Shower.
In your toilet. In your toilet. To wash away our pee-pee and our poo-poo. Like, you gotta admit, it's not a very thoughtful system overall. Like, if we had to go back to the drawing board and, like, reinvent a new society, these would be pretty easy ways to change that. In our current society, everybody's like, yeah, okay, so don't leave the water running while you brush your teeth, because that's something that we can just change. But if we were going back to the drawing board, using drinking water to get rid of your poo? My homie Rob, he's got this little sink in the top of his toilet tank. So he washes his hands, and that fills the tank for flushing. You know, like if there's not enough water, it still has a supply, so it's not going to turn, will just like sit there. But basically, he's using secondary water, like gray water, which is like, oh great, like that was already going to be wastewater, so he gets free turd flushings. There's so much water that we could, like, you know, you could use second grade water. Like all the water that exits all of your sinks and showers and other drains, that'd be fine for flushing away turds. I need to drink it afterward. Okay, anyway. Good times there. So I think we have talked about number 18, correct? That was number 18? Warning about number 19. Your book does fine. It's got a whole list. I don't plan to say anything about it, but it gets 2 stars on number 19. And number 20, I have a very interesting example for you. Does everybody here know how a bank account works with like deposits and withdrawals? Like, I think by now pretty much most of you have a bank account of some sort. Most of you? Yeah, that's cool. It's just class. Yeah. Dude, I don't care. I'm just screwing around. What do y'all get, by the way? What's your...
Candy and presents.
Candy? Performance food? You know that if you want to make sure there's always money in the bank account, you can only spend as much as you deposit, right? Okay. Believe it or not, that is the mystery of groundwater sustainability. You can only take out as much water as is absorbed in your groundwater. Mind is blown. If not, you get what's called an overdraft, which, by the way, that's what I'm talking about. So in groundwater, we use the term literally for banking account overdraft, like overdraft protection fees and whatnot. Yeah. And our Santa Barbara system is pretty much like the most ideal system anywhere. We have, please look up, mixed sources, groundwater recharge, state water backup. We have a pretty friendly reservoir. We recycle our wastewater. And by the way, we use our leftover wastewater solids to make natural gas, which is pretty cool. Yeah.
Do they have to put like the recycled, like using recycled water signs along the freeway and stuff on like random little spots?
So fun fact for you, that water is like drinkable.
So they like put it out for homeless people or something? Like,
I think that a homeless person could probably just go drink it.
but why do they like have to publicly, like there must be something like that they have to label it?
I think it's just like a liability thing, you know? Like they tell you the coffee cup is going to be hot. Like just in case, we don't want to get sued. There's only, I mean, honestly, there's pretty much just one time you don't want to drink recycled water, and that's like in the hours after a humongous rain. And even then, they usually don't put recycled water into the system, so it's pretty much always drinkable. What it does have, the one thing we can't take out of recycled water, anybody know what we can't take out of recycled water? What? Yeah. metals and medicines. So like all the antidepressants and stuff and all the birth control, like those background levels are actually like enough to measure. Like if you drank purely recycled water, it might actually affect your ovulation and your mood. Yeah, right, yeah. And you would get like pretty serious doses of heavy metals. You know the stuff that bioaccumulates up the food web? You would actually get like significantly real doses of that. Yeah, I mean, it's probably not as good as like full-on drinking water for you to have a regular supply. But the fact that it's only used for sprinklers, I think, is already like, I don't think people are gonna like walk up to the sprinkler and try to get like a full-on like chugging sprinkler water all the time. It's the only way you can drink it. So logistically, there's probably easier water right around somewhere, fountains. But yeah, okay. Check out Santa Barbara. Most of the time, we use the cheapest possible water. It's cheap because it's gravity fed. That's why we have reservoirs, because we can trap the water uphill. You just stop it uphill, and then you let it flow down to your city. So the reservoirs are by far the cheapest water. Then, if the reservoirs are starting to run out, now we got to start paying for some plumbing and some pumps. So once the reservoirs start to run low, please look up. We tap into the state water pipeline, the Central Valley Water Project. Please look over here. Most of these rivers are dammed so that the Sierra's water gets put into pipelines to irrigate the Central Valley. And the very last pipe goes through here somewhere, I don't know where. Through here, I think. Crap, oh yeah, it goes through here. And it ends at Lake Cachula. We, Santa Barbara, are the end of the State Water Project. But there's a lot of like plumbing along the way and some pumping houses to get it over hills and stuff. So this water costs us more. And if we really get desperate, then we start to use our groundwater. That's like our last resort in Santa Barbara.
Are we using that right now?
We are. And it looks like we're going to be using it faster than it refills because, you know, probably not a lot of rain in the forecast. Yeah?
What about our desalination plant?
So that's like, right now, you weren't here yesterday, that's kind of like the final frontier of desperation. We haven't used it since it was completed in the late 80s. And we haven't used it because it's just way too expensive. It's so much energy that we can't afford that water. It would be by far the most expensive of any of these. You take the most expensive, double it, and desalination costs more. And it costs so much because you have to buy all the electricity. By the way, the other problem with it is not just the cost, but the fact that the electricity produces tons of CO2. Yeah?
My mom was like telling me about something about how like Bill Gates invented some like sewage water purifying thing in Africa, and that we're gonna like start like exploiting that here or something.
So I think that the Bill and Melinda Gates Foundation helped popularize, or had a concept. Like he did not invent it himself, but his foundation is like pushing for these other like water treatment. Remember I showed you yesterday those like nanotechnology desal stuff? I think it's not nanotech, but it's like another high-tech system. I don't think those are municipal scale though. I think those are like pretty regional. But pretty like household. But then our state, the state of California, said, wow, we wouldn't want the groundwater to run out. Did anybody here follow the news about drilling for wells in Montecito in this last year? Montecito last year was getting roughly 6 new wells per day. Because everybody's like, fine, if you won't let me water my lawn, I'll just suck it out of the ground myself. And like, literally there was a little while there where people were like, whoa, 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 and you couldn't get, my homie bought property in Gaviota, and he needs a well, and they're like, yeah, our waiting time right now is 1.5 years. Like, if you want to start a business today, you start drilling holes for wells, but you've missed your chance, because all of a sudden there's a moratorium, because we're sucking out groundwater faster than it's added. So right now they're not issuing new well water permits, well drilling permits. And check this out. The state of California, at the end of last year, passed a new act. Please look up. It's called the Sustainable Groundwater Management Act. And they give local review boards so that cities can figure out like the supply-demand question. They fund conservation, so we use less water. They encourage recycling projects like we have to reuse. By the way, how does water recycling save groundwater?
We don't use it.
Right, because you don't use it. You're using the recycled water instead. Do you guys realize that all the schools and most of the parks that are irrigated by the city of Santa Barbara use recycled water? Do you guys know that? Plus a couple of our golf courses in Santa Barbara. So they encourage recycling. What do we mean by expanded storage? How do you store groundwater?
Leave it there. Do you have to store it?
Yeah, like where do you store it?
Like it's in the ground.
In the ground, yes. Believe it or not. You know, that concept is, yeah, precisely. You pay to have spots where instead of draining to the ocean, it soaks into the ground. So people, like, when they renovate a park, instead of making it drain to the street, they'll put a basin in the middle so the park is like a big-ass funnel to make more groundwater. Yeah.
Is the reason that they just like usually gutter it to the ocean is just 'cause it's way cheaper? It's easiest.
It's just like a convenience thing, you know? Like, nobody wants water everywhere. Like, mosquitoes and, like, slippery roads. And so, for a long time, our method of building cities was to get the water away. And now everybody's like, wait, but we need water. So everybody's, okay, never mind, keep the water, keep the water. So there's been this, like, change in how we plan our cities.
What if they just like put a bunch of dirt and plugged up those like gutters so that they like went into the gutter still, but just like.
Yeah, I mean, that's the other funny thing. We're going to learn on Tuesday about how streams absorb water, but that's too slow. So we've bulldozed all the streams and made them into concrete gutters just to dump the stuff faster. Channelization. Like, there's been this big shift. Like, you are living through a new way of thinking where people are like, instead of getting rid of water, we should probably start bogarting it because it's free drinking water. Please look up. Quality protection is preventing pollution of groundwater, like we talked yesterday with the E. coli situation. And anybody know why we would want more wetlands and watershed restoration?
Clean water.
Kind of for cleaning, and what else? What?
Protecting floods.
They protect from floods, but what's that got to do with groundwater? What?
It recharges groundwater.
That's right. Watersheds are recharge zones. What I was talking about with Jake. Okay. How many of you remember the wetlands conversation from the biomes at the beginning of the year? Okay. So, really quickly. Please look up. You know, wetlands, land that is sometimes wet. Your homework in number 21, which gets 2 stars. Your homework was outline the ways that wetlands provide natural services. And I wrote them down. I have a list of 6. Does anybody have more than 6? And before I gave you my list of 6, how many of you remember that analogy of like a sink and the drain and the sponge and the drain? Yeah, that's right. That's right. Okay, so here we go. I got a list of 6. Number 1, the groundwater recharge that Welch was talking about. They are these perfect sponges so that the water, instead of washing away, will soak into the ground. Number 2, the nursery effect. Did we talk about this? Where like all the productivity brings the bugs, and because of the bugs, it's a good place for the fish, and because of the fish, it's a good place for the birds. You know, nursery, like a good place for you to put your babies. Nursery effect. Number 3, bioremediation. What is that? What's the bio?
Like,
What's remediation?
Something like pollution.
Help fix something like pollution, exactly. So wetlands offer bioremediation. They fix water quality. Living stuff breaks up pollution. You got all the bacteria in there that help things decompose. You've got all that nutrient absorption that takes away extra nutrients. They are like living water filters. Number 4, what's special about coastal wetlands? Remember we talked about the tsunami and hurricanes. What's special about coastal wetlands?
buffer zone.
Buffer zones. That's right. They're a barrier to storms and waves. Number 5, what is the sponge effect? What's the benefit of that sponginess?
Stores carbon.
Stores carbon, yeah, that's actually number 6. We'll come back to that. What are the other benefits of the sponge effect? How does that sponge change what happens in the sink? If you put a sponge in the drain, what does that change?
Lets water out slowly.
Stores water and lets it out slowly. So they extend and moderate flow. They store it when there's a bunch and then let it out later slowly. You extend and you moderate the flow. It prevents flooding. Number 6 is the one that Welch said. Another nice thing about all that stuff decomposing in the water is carbon gets stored. That's how coal is made in wetlands. I hate it when he talks. I'll just pretend it was Welch. So status today, well, roughly half of America's wetlands have been developed, mostly for farms, sometimes for real estate.
Can you think of a better name than prairie potholes?
I don't know, it's a pretty good name.
What's that name?
I like that name.
If you think of a road.
And does everybody understand the amazing and sad irony of changing all of our wetlands into farms? Check this out. You've got the really good dirt in the wetlands, so you flatten it out to make it into a farm. Then on the farm you got to spray some chemicals, and those chemicals run back into the rivers, but that's bad for the rivers. So how do they prevent agricultural runoff from going to the rivers?
More wetland.
They build artificial wetlands, yes. It's kind of like a sad and hilarious trend, but in your generation, we're going the other way. Like when your grandparents were alive, we were like, oh my God, make them all into farms. And now we're like, oh crap, make them all back into wetlands. California's lost about 90% of the wetlands. The worst loss of wetlands is in the places that have a lot of agriculture. So the Corn Belt, the Prairie, and California. And does everybody remember what a bioswale is? What's a bioswale?
Like,
What?
Isn't that like when you have like a channel and then water runs through it and they put a bunch of plants in it?
Put a bunch of plants in there. It's a man-made wetland. It's a man-made wetland. Okay. So check this out. Please look up. Number 22 is a really big deal, as you can see. What is that? Let's call it, I think it's 2 stars. These are the environmental and social impacts of dams. Lucky for you, I wrote it all on the board. What does that say?
Poother.
Poother? It says poother. Why poother?
oh, I want a picture of the fever.
This is why bother, yes.
I thought it actually bother.
It says poother.
This is poother, yes, poother.
Why poo there?
All right. If we're going to talk about dams, we kind of have to understand what we're talking about, how they work. And so imagine I want to build a dam and you are the river flowing toward me. How do I build here when there's water in the river? Go further up and stop the water, then what's going to happen? And by the way, how am I going to stop the water? With a dam? Like, how do I make the stop?
You can build it where there's already like a partial obstruction.
So then how would I stop the river? Like, if it's partial obstruction, there's still water, right? How do you stop the water?
You redirect it so that it goes around the place so you're going to put it in a dam.
You redirect it so it goes around the place where you're going to put it in the dam, you know, like this. I make a hole in the canyon, right? It's called a diversion tunnel. Like that. My diversion tunnel. And then I take a bunch of rocks from the top and I drop them in right where you are. So the river raises a little bit and then goes boom. And diverts around, and then I get a dry spot. Please look up. If I want to build a dam, please look up. I want it to do this. Walk the river, make a reservoir, let some water through to run turbines before it returns to the river. Everybody see what I'm saying? The river flows that way in this image. The light blue is the water. So you build the dam to stop it. Then you use tubes to go around the dam. And you shoot some of those tubes through the turbines. Those are the red dots to make electricity. Hey Daisy, if you want to just set the time that they started, we can keep that experiment going into next period.
They just finished. They'll take 15 minutes.
Wait, they all went at the same rate?
No, like, it took 15 minutes for the last one to turn white.
Wow, that's really good timing. What's the secret?
Well, I just did like a 2-to-1 ratio of water and yeast, and then but also the yeast wasn't in the water for very long before I put it in the test tube, so I'm going to dump them out and try it again and see if the yeast is still alive.
Wow, this is spectacular. This is exactly what I'm going to need this week. This is awesome. So check it out. This, please look up, is the diversion tunnels. Right now, those are next to the river. So you would literally go up on the cliff, lower down on ropes with the river flowing beneath you. And while the river's like running under your feet, you start chipping into the rock to make that tunnel. You understand what I'm saying? You're like lowering equipment into a man-made cave and then keeping that cave parallel to the river. And when you pop out the other side, you gotta hope you don't fall in the river. There's like scaffolding and ropes and stuff, cables. Until you get this. So the water is elevated to the diversion tunnels by a temporary pile of rocks. There's your temporary pile of rocks. And that water is flowing through the canyon, and you can kind of see in this turbulence, it's spilling back to the river bottom. Now we've made that one little dry part at the bottom. Does that make sense to everybody? Now you got a spot to work. So you start to build up a berm, start to pour the concrete. This is lots and lots and lots of concrete. There's some people, like apparently the concrete at the center of Hoover Dam has never dried because they were in such a hurry that they just kept piling it on, and like the stuff at the bottom never fully cured. It's like kind of flexible.
That's kind of sketchy.
Yeah, like I can't tell if that's a good thing or a bad thing, and I'm under the impression it was engineered that way. It's to give it like a little squishiness, which is supposed to be kind of good. I don't know, man. Like, it sounds sketchy, right? So check it out. Build it up. Get that nice sharp edge at the top with the roads and the towers and whatnot. You put in some little tiny bits of plumbing, little valves and stuff. Then you build these. They're called overflow towers. This is how the water exits the reservoir. It spills into these towers. That way boats don't get sucked in and stuff. And then you build the electrical generators down below. There's your completed reservoir. Please look up. I'll try to explain what's happening in here. These are the overflow towers. So the reservoir pours into these columns. Then back inside the reservoir, at the bottom of those columns, they're being pushed into pipes that are inside the cliff. And there's little valves that let water go from the pipe into these turbines. And this is where the water exits. So you can tell they're making electricity right now because there's water coming out of the turbine holes. You can also tell that they're getting rid of extra water. You what?
You can't see the overflow thing.
Yeah, I guess not. They must be there. I don't know why you don't see them. These are actually two different, this one and this one are different dams. So maybe the turbine, maybe the overflow towers are in a different spot in this one. These are not the same. You guys notice that that's a different dam?
There's a bridge that wasn't
What?
on the second dam. There's a bridge that wasn't.
Yes, right. So, you've got to know the environmental and social impacts. Lucky for you, I've actually made this handy thing on the wall, but I need to talk about a few of them. So there are, please look up, changes to the river, changes to the ecosystem, changes for humans, and the reasons why we might want to. I'd like to start there. Why do we bother with dams? 4 reasons. You get drinking water. That's very nice. We like drinking water. You get electricity, which is increasingly appetizing because this is carbon-free. Sometimes you get some recreation. It depends on what you find recreational. But like in the 1940s and 50s, telling people that you can come and swim and fish, that was actually pretty sweet. Like, your grandparents' generation, this was like their nature access. Nowadays, we like modern hippie types, we think that this is like tacky, not really recreation. But for grandma and grandpa, like this was nature time. So the recreation was a big part of the sales pitch. And finally, you get flood control. Remember that in the, like not too distant past, floods were pretty scary. People who live along rivers, that's a big threat. So, I have broken up my impacts into uphill and downhill. The most basic stuff is you flood canyons, so you make a much bigger lake where there used to be a trickle flow. You waste a lot of the water through evaporation. That's a general problem, that the water evaporates. You'll understand when the water sits still closer to the surface, there's more wind and more sunlight area, so it evaporates more, right? That makes sense to everybody? That you lose more to evaporation? Does it make sense to you? You making fun of me? You don't lose more to evaporation?
Wait, but versus just leaving it as a river?
Yeah, so when you leave it as a river, it's lower in the canyon, so it's not as subjected to winds, and temperatures from the bottom to the top are usually very significantly different. Feel me? Because this is like buried down in the earth, so the water down at the bottom of the canyon is always much, much cooler than elevating the atmosphere. So you get increased evaporation, and just so you know, on the Colorado River, that's roughly half the water volume. Check this out. With everybody trying to keep water, each of these evaporates roughly half its water volume per year. So overall, you're losing a lot of water. Likewise, that slowing of the water traps sediment. And this is the key problem with getting rid of dams. How many of you have heard about dam removal and like the controversy about getting rid of dams because it's bad for salmon and people want to get rid of dams? We have one nearby in Matilaha that people want to get rid of, and the problem is that reservoirs fill up with sediment. Look at the flow rate. At Glen and Boulder, it's the equivalent of 2 dump trucks per second that have been added every second in the history of the reservoirs. You know, because the water's flowing over the desert and there's wind and there's sediment in the rivers, that just keeps getting delivered and building up. Today, the first dams we built in the United States are about 50% full with just dirt. Their capacity is down by half. When my students say, oh, we should get rid of the dams, this is the reason you can't. Getting rid of the dam is not the challenge. Dealing with like hundreds of millions of tons of sediment, that is the challenge. These are the uphill problems. Downhill, you get salinization. Anybody know why you get salinization? Has something changed with this class? I don't know if it's the new seating arrangement or something, but you guys are so checked out. I'm really worried for you. Yes?
Is it all because of all the evaporation that more salt is put into the dam?
It is exactly because of all the evaporation. And thanks for getting back to the point, but do we need like an intervention moment where we can all like talk about what's going on? Because I'm really curious. Like there has been a, am I the only one who feels the nosedive, or does anybody else feel the nosedive?
Yeah.
So what is up with that?
It's about to be a 4-day weekend.
I think it's because it's break
Yeah.
Second semester.
It's Friday.
Everyone's thinking about their plans.
So this is happening in all your classes?
Yeah. Wales from Elliptical Friday.
This is only happening in my period too.
Can I just sit on the floor with that?
I'm okay with that. Okay. Is that what it takes? Like I bribe you with beneficial seating and then you engage in the course?
Yeah, you do kind of
That, that really sounded
I
bro.
feel like bobble
Yeah, exactly.
and leave, you know. Like when you sit there, I couldn't see you.
So what that means is that you just like don't do the class anymore? Like I'm
No,
just kind
that's
of
not
like
right.
I'm just wondering what's changing about the class overall. Like that's interesting, but like that's what everybody, that's the whole deal? Yeah, some people are still like fully in it. I don't know. I just wanted to say, maybe this isn't the right time, but I'm really stressed and something's changing. Yeah, maybe I should have waited until like the makeup moment, but like there's something changing about period 2, and I'm very worried about it. But thank you, Welch. Back to the course. Yes, the salinization is a really big look. The salinity roughly doubles at every dam. So check this out. We are the only country on Earth that has a desalination plant on a river. Because you realize that when you double something 11 times in a row, that's an exponent of 11, right? Does that make sense? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, so on. And so the salinity of the Colorado River when it crosses the border into Mexico is higher than the salinity of the ocean. And Mexico says, you're wrecking our river and that's killing our wetlands. International lawsuit, U.S. goes fine, and we built a desal plant on a river. Because of this. It's a really serious issue. The water coming out is extremely salty, especially after that many dams in a row. Also downhill, you've got clear and cold water. That's the opposite. It used to be warm, and it used to be silty. But we settled out all the sediment, so it's clear, and we keep building these giant pools and then taking the water out of the bottom. So down there, the water gets really cold. You have this huge differential, so the water's now clear and cold downhill. Plus that loss of sediment, that's really disruptive downhill. We'll look at that in the ecology part. Yeah?
So it used to be warm and silty?
Yeah.
So it used to be all murky and stuff?
Yeah, I mean, it was like mud river.
Oh.
So by being shallow, it was all like at a medium temperature. Now, the top is really hot and evaporates, but that's not the part that you use, that's not the part that exits the reservoir. The part that exits the reservoir is the deep, deep, deep water. And everybody knows the bottom of the ocean, bottom of lakes are really cold. That's the stuff that we let go. Does that make sense? Yeah.
Isn't Gibraltar Dam loaded with sediment?
Gibraltar Dam is loaded with sediment. I'm sorry that we couldn't finish this.